Geometry chapter 4 lesson 5. First 5-minute check over lesson 4 and after that we will know how to prove two right triangles are congruent. Number 1, here you have many triangles. We want to write triangle WXY is congruent to which triangle by using angle side angle. Okay, WXY from this angle to this and to Y will be congruent, the same, this like this and this like this. So you have to write VZY by using angle, and side between two angles. Then your answer will be letter B. Two triangles WYZ, WYZ. From here, this angle will be congruent to this angle, YZ, and this angle will be congruent to this angle by vertically opposite angle, and this side like this side. So your answer will be letter A, which is triangle VYX. Number 3, by using side, we want to write triangle VWZ is congruent to which triangle? VW equals to VW, another triangle. WZ equals to VX. Then you have to write WVX by using side. The order is very important in congruency statement, as you know. And in this lesson, we will have two right triangles. To prove two right triangles are congruent, first, two right triangles, this means you have a right angle. So, you have many ways, 1, 2, 3, 4 ways. First way, when you have two legs, two sides of right angle is called legs of angle. If you have two corresponding legs are congruent, then your triangles are congruent. Remember, this like which one? Like side, angle, side. But here is called LL. Other way, HA, YH. H for hypotenuse and A for any angle except right angle, because we have two right triangles, so it's clear right equals right. Now if you have angle equal angle and two corresponding hypotenuse are congruent, two triangles will be congruent. And if you have LA, L for a leg, A for angles, but here you have to know this side between the angle and the right angle and the right angle. And here you have LE, which is hypotenuse and leg. If your two corresponding hypotenuse are congruent and two legs are congruent, and we know we talk about right triangles and two right angles are congruent, so two triangles are congruent. Lesson.
Welcome to McGraw-Hill Personal Tutors. Determine whether each pair of right triangles is congruent. If yes, include the theorem or postulate that applies and describe the series of rigid motions that map one triangle onto the other. The two figures in part A, you can see that we have a right triangle and one dash along the base and one dash along the altitude for the second triangle. Both pairs of corresponding legs are congruent, so that's important to note. Both pair of corresponding legs are congruent. So the triangles are congruent by leg, leg. You will often see this abbreviated as LL. The first triangle is mapped onto the other by a counterclockwise rotation of 90 degrees and a translation. So if you can picture a counterclockwise rotation of 90 degrees, it's as if this was falling. So our 90-degree angle ends up here, the base with 2 marks, and then the base now becomes the altitude. So we have a 90-degree rotation and then a translation. So our rigid motions include just that, a counterclockwise 90-degree rotation and a translation. For figure B, you'll notice that we have the 90-degree angles marked and the hypotenuse. There is not enough information to determine triangle congruence. At least one pair of corresponding legs or one pair of corresponding acute angles must be congruent to show that these triangles are congruent. So once again, at least one pair of corresponding legs or at least one pair of acute angles must be congruent. Thank you for using McGraw-Hill Personal Tutors.
Example number 1. Here you have 2 right angle triangles and we want to find 2 triangles are congruent or not. Here you have 2 corresponding legs are congruent and clear 2 right angles. So you can use, okay, leg, leg. Then, yes, 2 triangles are congruent by using LL. Transformation here is translation and this is not important. You have to know only the very important thing to write your reason, which is LL. Yes, congruent, LL. Here, we want to prove two triangles are congruent. Here, you have two parallel lines, HG parallel to EF. Remember, when you have parallel lines, you have to search about two congruent triangles by alternate or corresponding, or interior angle will be supplementary. Here you have alternate angle, interior, like HGE. This angle will be alternate to this angle, FEG. Two angles are equal. Okay. First, you have two right triangles. Two angles are congruent with two right angles. And here you have common side, which is EG, and EG is the hypotenuse. So you have H. Then you have to find other angle or other sides. And here side is called leg. So you have two right angles, angle F and angle H, and you have common side EG. You can write EG equals EG reflexive, or you can write common side. And from parallel you get two angles are congruent, alternate interior. Okay, now you have hypotenuse and angle, so you have to write HE, and you have to write congruency statement like this way: triangle EFG is congruent to GHE.
Welcome to
Now
McGraw-Hill
lesson.
Personal Tutors. Write the specified type of proof. Part A, flow proof. Given triangle JKL and triangle JML are right triangles with right angles angle K and angle M, and segment JK is congruent to segment LM. Prove triangle JKL is congruent to triangle LMJ. Let's take a look at the diagram given. Triangle JKL and triangle JML are right triangles. So you'll notice that we have our right angles at M and also at K. Angle K and angle M are right angles. We're also told that JK is congruent to segment LM. JK is congruent to segment LM. So with our flow proof, we're putting our information in some boxes here. Now, underneath this first box, where angle K and angle M are right angles, we'll write the word given, because it was given in the sentence. Same with the next statement. JK is congruent to LM was also given in our proof. From here, it's time to look at the diagram a little bit further. You'll see that side JL is the hypotenuse of both right triangles. JL will be congruent to segment LJ. We'll put that in a rectangle. And how do we know that? That is our reflexive property.
In a rectangle. And how do we know that? That is our reflexive property.
So if you look at the diagram, you can see that we have the hypotenuse JL
So if
and the hypotenuse LJ of both triangles.
hypotenuse JL
So we can reach the conclusion
hypotenuse LJ
that triangle JKL
so we can reach the
is congruent to triangle
triangle
LMJ,
is congruent to triangle LJ,
and our reason will be HL, which is
will be
hypotenuse
L,
leg.
which is hypotenuse leg.
So for our flow chart, the given
So for
feeds
our
in
chart,
and our reflexive property also feeds in. Triangle JKL is congruent to triangle LMJ by hypotenuse leg.
triangle JKL is congruent to triangle LMJ by hypotenuse leg.
Part B, 2-column proof. Given angle QSR and angle QST
Column
are right angles,
given
S
angle
is the midpoint of segment
QSR
RT.
and angle
Prove
QST
triangle
are right angles.
QSR is
S is
congruent
the
to
midpoint
triangle
of segment RT.
QST.
Prove
So our
triangle
2-column proof
QSR is congruent to triangle QST.
is exactly that. We have 2
So our
columns.
two-column proof,
On the left, we put the statements,
we have 2 columns.
and on the right, we put the reasons.
And on the right,
Often, the first statement will be the given, and we'll do exactly that. Angle
the first statement will be the given,
QSR,
and we'll do exactly
which is already marked in the picture,
angle
and
SR,
angle
already marked in the picture,
QST, once again, already marked in the picture, are right angles.
QST, once again, already marked in the picture, are right angles.
And our reason is given.
And our reason
Statement 2. Triangle QSR
Statement 2. Triangle
and triangle
QSR
QST are right
and
triangles.
triangle QST are right
And the reason is the definition
and
of
the
right
reason
triangles.
is the definition of right triangles.
A triangle with a 90-degree or a right angle. Statement 3.
A triangle with a 90-degree or a right angle.
Segment QS is congruent to segment QS.
Segment
And we'll mark that in the diagram.
is congruent
We can see that
QS.
is the reflexive property.
And we'll mark that in the diagram. We can see that is the reflexive property.
Statement 4. S is the midpoint
Statement 4. S is
of
the
segment RT. And how do we know that?
of segment
It's given.
RT. And how do we know that?
Statement 5.
Given.
Because S is the midpoint, we know that it's right in the middle of R and T,
Because S is
which means these two segments are congruent.
that it's right in the middle of
So
R and T,
RS
which means these
is congruent
are congruent.
to ST,
So RS
and that is the midpoint theorem.
to ST, and that is the midpoint theorem.
If you take a look at the picture, you'll see that we have
If you take a look at
QS
the picture,
and QS congruent. We also have SR and ST congruent, which leads us to the end of our proof
SR,
that triangle QSR
which leads us
is congruent to triangle
triangle
QST, and that is because of leg.
ST, and that is because
Thank you for using McGraw-Hill Personal Tutors.
Thank you for using McGraw-Hill Personal Tutors.
Example number 2. Write two-column proof, or any way to write your answer, but you have to write the reason for anything you get. Here you have JL parallel to KM, JL parallel to KM. Then you have to find, two alternate angle or two corresponding angle. Here we have alternate angle MKL and KLJ. Two angles are equal by using alternate interior. And two triangles are right, triangle JKL and KLM. Now you have to think about your way to prove that triangle JKL is congruent to triangle MLK. From parallel, you can get angle JKL and angle MLK are right. This is given, and from parallel you will get angle JLK and angle MKL, alternate interior. So two angles are congruent, and you have common side by using reflexive property, which is KL equals to LK. KL and LK, this is leg, and you have angle. Then you will prove two triangles are congruent by using LA, leg and angle, and your congruency statement JKL is congruent to MLK. Thank you.